Hello. I'll be talking first about myself. I'm Pavel Grochal. Currently, I work for Inuits, and I really love Python. Just a side note, the Inuits is currently hiring, so if you would like to work on similar projects I'll be talking about, just contact me after the talk. And now something about a Streamparse. So the motivation why I need to use this technology, and I love that, was because we had a lot of data, GPS data, that comes real time, and we need to process them. So let's start with Apache Storm, which is like the basic foundation for that. Does someone know Apache Storm here? 3-4 people, okay. So I'll be talking for a short time about Apache Storm, so we are on the same level. So Apache Storm is somewhat a real computation system, somehow. It consists of a master node and some worker nodes, which could be, say, machines. The master node has Nimbus on it, which is the brain of the whole computation thing. And on the worker nodes, there are supervisors that supervise if the computation is running, and the worker process, or processes. And let's look closer on the worker processes. The worker process has some executors and tasks. And on this level, you can imagine the task as a Python process, or any process, but in our case, it will be Python processes. Also, to make some clarifications, we'll be talking mainly about 4 terms. So the tuples, spouts, bolts, and topologies, which I'll explain briefly on this image. So when you're dealing with processing data, you have to describe how the data will be processed. And it is described in a topology. So on the left side, you have spouts. Spout is something that generates data. It takes the data from somewhere, let's say database, RabbitMQ, or whatever, and it will send the data to other processing parts, which are called bolts. So Spout doesn't have any input. It generates data from somewhere and pulls that to bolts, and bolt has some input, does some stuff, and optionally it can pass data to another bolt. So far, so clear? All right. So the process we need to do is read some data from RabbitMQ in our case, then process the data like reverse geocoding, speed limit lookups, and whatever, and then to store data somewhere else. So this is where I should say how the Streamparse fits in. First, I'd like to thank you, a company called Parsley, which maintains this thing and open source it. And the answer is you can write topologies in Python, which is wonderful. I'd like to state some dependencies. It's not many, so you have to have installed Java on your computer, possibly version 7+. And the other two, the Lineagen and Apache Storm development environments, are just, you can download these things from the internet, put it in a path, and it will magically work. That's it. You can read more about that on dependencies in a quick start. And let's go to the Streamparse. So as the Streamparse tries to be as user-friendly as possible, it likes to be like Django. You just write serve run, and it magically works. So they included a quick start you can easily start with. So by running, can you see the text also in the back? Perfect. What it does, it generates basic structure. So sparse, which is command line tool, quick start word count generates the structure. So one by one. The first thing is words. Oh God, never mind. So this is where the first spout is. In this quick start example, it just generates 4 words on and on. So in the initialize method, which is called after some initialization in it, and then once on the start, you just get words. We just cycle these 4 words. And then there is a method next tuple, or tuple, whatever you prefer, which takes the next word and just calls self-emit. And that's it. So this is how you send data to other bolts. Okay, we have spout, where the data is taken or magically created from somewhere. So we need to process the data. And this part is in a bolt. So in this example, we have word count bolt. And it has also 2 methods you need to implement. The first is initialize, which just initializes some counter for us. And what this bolt should do is count the words that it came to him. So in a previous slide, we were sending dog, cat, zebra, and elephant. And in this bolt, if the word comes, it just increases the counter. So in a process method, it reads the word from a tuple that it gets, increases the counter, does some logging information, just if you run it, you know. And it would also emit the thing to another bolts in topologies. As you can see, in a spout, the tuple was just consist of 1 part, word, but it doesn't limit you to anything. So in another bolt, we have word and the count of the word. So we can play with the data. And the third part you need to know is the topology definition. So we have spout somewhere, we have a bolt somewhere, and we need to connect them somehow, which is done here. So there is a class from topology, and you define the word spout, the count bolt, and you just say that this bolt takes input from a word spout. And that's it. Streamparse also have a neat function called sparse visualize. It will take your topology and create an image called the same as the name of the topology, where you can see the bolts, the spouts, similar to this image. So you know how your topology works, because if you have like 30 bolts and spouts, it gets messy to look it on the code, in the code. I also have to say that the topology has to be directed acyclic graph. So it means it has beginning somewhere, has an end somewhere, and doesn't contain loops. And besides these 3 files, the Quick Start project generated 4 more. And I like to show you it's not magic in these files. So let's start one by one. The first thing is config.json. This file is used by the sparse command line utility, so it knows what and where it should work. So first, you have some definitions where the topologies and virtual environments for Python are stored. And then you have definition of environments. And here you can define like development environment, production environment, staging environment, whatever. And via the command line tool, you can say, okay, I would like to upload the topology on dev environment or production environment. So the Streamparse also helps with deploying topologies to the Apache clusters. But let's talk about config.json later. I'll have more examples. There's also a fab file. Maybe someone of you know fab. Because the Apache Storm doesn't allow to bundle the virtual environments for Python. This is basically used when the Streamparse deploys something to cluster. It has to create the virtual environments, or you can do it by yourself, but it helps you. So it connects by SSH to the cluster, and here you can do things before and after submitting the topology. All right, the third file is project.closure, CLJ. This is the only file needed to be written in a different language than Python. And it's because this file is taken directly by Apache Storm. But since the syntax is not that hard, at least I hope so, you can easily live with that. At least I could. So in this file, you'll define how your topology is named and some basic stuff where all the parts are. All right, and the last file is very simple. It's just definition of virtual environment requirement file. And the only requirement there is you need to have Streamparse there. And that's it. So I hope now I clarified all the magic. And if you do sparse run, it will run the topology in your memory. So the output looks something like that. It will first create the jar, do some details, and runs the topology. So if you can recall, we were logging the information. So it just logs how much it gets called, and it's continue. I encourage you, please, if you're interested, just there's a quick start tutorial on the Streamparse documentation. It wouldn't take you more than 5 minutes, and by sparse run, you can get these results and start coding, which I think is wonderful. All right. So here comes the part that it's not that basic, and I'll try to explain. But you don't need to know this stuff to get topology running and working. So bear with me, please. If you run the topology locally, what it does, that Streamparse takes another component, which is called flux, and the flux somehow wraps the things needed and communicates with the storm, so you can run it in a memory. So if we take a look at documentation of flux, we can read that it's a framework for deploying things to Apache Storm. There are examples. So to run topology on a flux, you just call storm, which is the binary from one of the dependencies. Jar, you have the jar where all of your source code is. The Streamparse create the jar, which is wonderful. Then the flux, local, and some config YAML file. So there are two things needed, the jar and the config file. And if you can see on the sparse run, it will create the jar and run the flux command. So somewhere it creates the jar, here. And also there's the YAML file. So let's take a look at these files. I hope that most of you know what jar is. Is there someone who doesn't know what jar is? Okay, so it's a package for Java, and it contains a lot of things. And in this particular case, it contains all the dependencies the Apache Storm needs, so the Java files. Also, it includes all the source code you were written in a src file, and also the project.closure. I was telling you that the Apache Storm needs this. And the YAML file, if you look closely, it will resemble the topology config we wrote in Python. And that's basically what Streamparse does. It takes the topology Python definition and transfers it to YAML file. So we have the word spout, word count bolt, and so on. Oh. So it's that easy, let's say. What happens if we want to deploy Streamparse on a cluster? There is one more thing called thrift.py. So let's start from bottom up. What Apache Storm says, that the core of the Apache Storm is basically a thrift definition. So what is thrift? Thrift is a software that can combine multiple languages together and run it. And if we move further, the thrift.py is just a pure Python implementation. So again, there is no other dependencies than Python. Now, I was talking that we get to config JSON later, so here we are. So if you want to deploy things to the cluster, you have to have cluster somewhere, but that's part of how to install Apache Storm. And for the Streamparse, you need to tell Streamparse where to find the cluster. So obviously, you need to fill this part, the environment you want to deploy, submit topology in. So you define the SSH user, SSH password, where the Nimbus server or the brain is, and where are the workers. Streamparse needs to know where the workers are because it creates virtual environments for you if you want. If no, you can do it by yourself. And there are some other options I'll mention later. And if you do sparse submit, and you can optionally specify either environment and a topology, because you can have multiple topologies in one project, why not? It will start deploying. So the only other thing is connecting to the Nimbus. You can see there's updating virtual environment. And what happens there is basically it uploads there a requirements file and run pip install R the file and overwrite anything. Then it uploads jar and tells Nimbus, hey, here you have a jar, please submit that. So here's a part where we look at the source code of the Streamparse. So this file is not in our project. It's in a Streamparse project /CLI/submit.py. So this is what happens when you write sparse submit. And as you can see, this is the part where the thrift comes in. It basically gets the Nimbus and allows connection with the Nimbus, submits the topology, and it is the only different thing between running locally and on a cluster. So we just added single component. So this is the mechanism how it works on a background. I hope I didn't scare you that much. Still, you need to know just the Python and the free files or several files to get your topology and processing running. All right, here comes the part where it's more specific and things I've encountered during my journey through using Streamparse. So we need to send a custom configuration to either whole topology. So there is an option. In a config.json file, you can have options, sub-directory or sub-thing, and you specify there your options you want to pass to the whole topology. And later on, in either bolts and spouts, you can read those values. I'll show you. So here is my other custom configuration through whatever. Also, sometimes you want custom bolt or spout configuration. So for example, we are having RabbitMQ spout, which connects to RabbitMQ, and connects to some queue and reads the files from the queue or the data. And to be reusable, we need to define the Rabbit MQURL and from which queue it should read. So you can do in a topology.py, in the topology definition, there's a config part, variable, and you just send a dictionary there. So you say Rabbit MQURL is this, the queues are this. And then in the spout, you can, in an initialize method, read it from a stormconf variable. So you just stormconf.get. And this is exactly the same name as in a spout definition. And I also told you that you can read the variables from the JSON config file. So here is the my other custom configuration we stated on a environment-wide file. Another thing, as a bonus, you can mix Python and Java components together. So for example, if you find this wonderful spout for Java that can connect to another queue, you can use it. Why not? The only difference, and this is from documentation, so it's exactly the same as in documentation, is that you need to define few more things in the topology definition, like full class name, which is the path to where it should look for the Java component instead of for Python. So it's not that hard to mix Python and Java together because, you know, Apache Storm is written in Java primarily. So you will find a lot of good spouts and bolts written in Java. And the last thing I want to talk about is what we struggled with, because it was the hardest part. I was tinkering with Streamparse. So let's start how the Python process is spawned. So you have somewhere the Apache cluster. I told you about the workers. And what basically does, that the worker runs something called shell spout. If we use Flux, it's Flux shell spout that extends shell spout. And this Flux shell spout does some communication with Apache Storm, and then it just spawns the process and communicates via this process with standard input-output. It's defined in a documentation for multi-length protocol. You can look it up. We have a Python process, but the problem was we need to somehow change how the Python process was spawned or created. So also, there's a way to do that, and this is a very, let's say, nasty hacking. Don't do this ever, but it's possible. You can include your own Flux shell bolt, Flux shell spout, which is Java class definition. So again, in a Streamparse project, not in our project, I want to show you that there's a method that takes the specification of bolts and spouts and converts to the YAML file, which Flux takes. And while it generates the YAML file, it states the Flux shell bolt and Flux shell spout. So if you look at the Flux dict from which the YAML is generated, it states that yes, use the Flux shell spout, which will be spawning the processes. Here are the source code if you want to look. But we needed our custom files for spawning the Python process. So if you create the dictionary called anything, Java dependencies in my case, and you specify the correct path for Java, and the xflux shell spout, xflux shell bolt. Here is how the xflux shell spout can be. So I'm just extending the flux shell spout and doing my custom stuff. You can do two things to include these Java files. The first is that you need to state in your project closure where are your Java classes. So you say, yes, here is the folder where you can look for Java classes. And the other thing, and that's quite hacky, is changing the Streamparse source code. So it doesn't create the Xflux shell bolt or Xflux shell spout. Or the other way you can do it is to change the YAML file. So you just include our Xflux shell bolt, Xflux shell spout, and you have a control over the spawning of the Python process. So from where the Apache Storm used Flux shell spout, we substitute for our custom Xflux shell spout, and we also have a control over how to spawn the process for a Python or whatever you need. Thank you for your attention, and now I'll answer questions if there are some. All right, the first one, examples of problems Streamparse can help solve. It's real-time processing framework. Because I like Python more than Java, I was glad I can write all things in a Python. So the first thing it could solve, you don't need to learn Java. The second one, the second one, we need to process a lot of data in a real time, the GPS data, and it's proved quite useful. And also a company that maintains the project, Parsley, is using it for quite a large project. Check that out. I hope that I answered the question. Oh, all nice so far, but what is it for? I guess it's nearly the same question, or if someone can explain it a bit, who asked? Yeah, so what the Streamparse can do with the raw data and what it was used for. So in our case, we get raw GPS data, and we need to do the reverse geolocation. So from the GPS point to get the address and street and all the things. So we have, let's simplify that. We have Spout that takes the data from Rabbit. We have a bolt when it queries some server, and it sends the GPS data, gets back the response, and the third bolt that stores all the data to database so we can use that later. Was it okay? Okay. Can you use Streamparse for real-time streaming data from MySQL binlog? I don't know what MySQL binlog is. So you can reach me after the presentation, we can talk. They also run batch processing. Again, sorry, I don't know Lambda architecture, but there is a thing called batching bolt, which you can send the data in batches. So for example, if you're saving things to database and you're processing like million data per second, you don't want to query or store things database a million times a second or million times a minute. So you can say, okay, just process this data or push the data every 5 seconds. And I hope I answered the question. What is your traffic requirements per second? And how many instances of your job are running for handling that traffic? Sorry, I can't say that. Looks like a lot of boilerplates. Have you assumed PySpark streaming? Yes, we're also looking in a PySpark streaming. And I believe tomorrow is a workshop for PySpark. So you can have your own comparison if you go to the workshop. Have you encountered any Storm stability issue in production? Yes, we were using Storm version 0.9, and it wasn't that much stable, or it was stable enough but had some issues, especially it was quite slower than it is now. But since the release of 1.0.0, the things are wonderful, so I don't see a problem. Maybe because the Storm can ensure the reliability, so the data get processed through the whole chain, or it can signalize Storm, sorry, there was some error, you need to process the data again. And also, if you can have multiple same bolts, so you can distribute the workload over a lot of servers or a cluster of servers. If you look at another presentation for Streamparse, it's how to beat Python GIL with the Streamparse, because it's spawning multiple processes, so you don't need to bother with GIL. And last, have you done any performance test between Python version and Java version of your bolts and spouts? Sorry, we did not. We used Streamparse, and it was sufficient to run it just in Python, so we didn't have options/time to compare the versions.
Do we have any more questions from the audience? We do not. Okay, thank you, Pavel.
Thank you.